Good morning to one and all. Myself Divya. Today my topic is about decoders. What are encoders and decoders? In a digital electronic project, the encoder and decoder play an important role. It is used to convert the data from one form to the another form. Generally, these are frequently used in the communication systems like telecommunication, networks, and transfer the data from one end to the other end. In the same way, it is also used to digital domain for easy transaction of data placed in the codes and then transmitted. At the end of the receiver, the coder data are collected from the code and then processor the process to display. This article discuss what is encoder and decoder working and their application. Decoder is a circuit used to change the code into a set of signals. The name itself tells us decoding means it reverses of encoding. The decoders are very simple to design. Here we have I1 and I0 selection inputs and the outputs are Y0, Y1, Y2, Y3. Decoder is a combinational circuit that has n input lines and maximum of two, 2n output lines. One of these output will be active high based on the combination of input presents when the decoder is enabled. That means decoder detects a particular code. The output of the decoder are nothing but the minimum terms of n input variable lines which is enabled. So we will have the n input lines and 2n output lines in the decoder. This is the major difference between encoder and decoder. Truth table of decoder. The encoder and decoder are designed with the logical gates such as AND gate. There are different types of decoders like 4, 8 and 16 decoders. The truth table of decoders depend upon the particular decoder chosen by the user. The subsequent description is about the 4-bit decoder and its truth table. So 4-bit decoder. So in this we have n output lines as A and B, and outputs are D0, D1, D2, D3. Four outputs as it is 4-bit decoder. So four output lines, and here we have the NAND gate, NOT gate, and AND gates, and 1 and 0 logic. Based on that, the circuit is designed. The 4-bit outcoder table, truth table is 0 0 if all 0 0, and if the selection inputs are 0 0, then all except d0 everyone is 0 0 1, then the d1 is 1, and 1 0, then d2 is 1. If all ones, d3 are 1. Binary decoder. In digital electronics, the binary decoder is a combinational logic circuit that converts the binary integer to the associated pattern of the output. These these are used to these are used in different applications like segment display, memory address decoding. The function of the binary decoder is obtained if the given input combination has occurred. 2 to 4 decoder. 2 to 4 decoder has two inputs A1 and A0 and four outputs Y3, Y2, Y1 and Y0. These are block diagram of 2 to 4 decoders. Here we have A1 and A0 are the inputs and these are the outputs. One of these four outputs will be 1 for each combination of input where enable is E is 1. The truth table of is shown below. If enable is 0 and a1 and a2 are don't care, and if enable is 1, for remaining all cases enable is 1, and here inputs are 0 0 0 1 1 0 1 1. These are the outputs. Implementation of higher order decoders. Now let us implement the two higher order decoders using lower order decoders such as 3 to 8 decoders, 4 to 16, 3 to 8 decoders. In this section, let us implement 3 to 8 decoders using 2 to 4 decoders. So to implement 3 to 8, we use 2 to 4 decoders as it has two inputs A1 and A0 and 4 outputs Y3 to Y0. whereas 3 to 8 decoders has three inputs A2, A1 and A0 and 8 outputs Y7 to Y0. We can find the number of lower order decoders required for the implementing higher order decoders using the following formula. And M1 is the, here the required formula is number of ordered decoders as M1 and M2, where M1 is the number of output lower order decoder, M2 is the number of output higher order decoders. M1 equals to 4 and M2 is 8. Substitute the value in the above formula. So we get M1 by M2. So 4 by 8 is 2, whereas we equal 2 to 4 a 4 2 to 4 decoders for implementing 3 to 8 decoders. So to implement 1 3 to 8 decoder, we have to implement 2 to 4 decoders, as it is shown in the below. 2 to 8 decoders. The parallel inputs are AN1 and A0 are applied in each 2 to 4 decoders. The implementation input is A2 is connected to the enable, and for zero case it is enable as inputs as don't cares and remaining all enables as 1. E of the lower A to 8 is ordered to get the output as Y3 to Y0. There are lower 4 minimum terms. The input A2 is directly connected to the enable E upper 2 to 4 decoder in order to get the output as Y7 to Y4. These are the higher 4 minimum terms. Here we can see the circuit diagram of logical circuit, where to implement 3 to 8 decoders we use 2 to 4 decoders as 2, and to implement 4 to 16 we use 3 to 8 decoders as 2. 3 to 8 decoders, it is called 3 lines to 8 lines decoder because they have inputs 3 inputs and 8 outputs. To decode the combination of 3 and 8 we require 8 logical gates, and they design this type decoder we have to consider as required active high outputs. The below shows that decoding of 3 lines to 8 line decoder. To design this type of decoder we need active high outputs and the given input combination. The decoder output is 1. The tabular form is created in this way. Here we have 3 to 8 decoders, 3 inputs A0, A1 and A2, and remaining these D0 to D7 8 outputs. The truth table is, if all the cases are all the inputs are zeros, then D 0 is 1, and if A 0 is 1, then we get D1 as 1. In this way the truth table is derived. From the truth table of 3 lines input to 8 line output, we can show that the logical circuit consists of 3 NOT gates and 8 NAND gates. Pin of the NAND gates are connected together. The NOT gate can be generated the complement of the input, and the NAND gate can generate the produce maximum terms of each of the output. And here we have the 3 to 8 logical circuit decoder. Then application of decoder and encoder are speed synchronization of multiple motor in industries, Warfield flying robot with a night vision flying camera, a robotical vehicle with the metal detector, RF based home automation system, automatic health motorized system. Thank you.